Hello, welcome back. We are on chapter 7, rational exponents, radicals and complex numbers. And today we're going to work on section 7.6, radical equations and problem solving. The first objective is to solve equations that contain radical expressions. And let's have a look at the power rule. If both sides of an equation are raised to the same power, all solutions of the original equation are among the solutions of the new equation. And this is important because that means sometimes we're going to have solutions that are not applicable to the original equation, and that's the reason that's very important to check the solutions that you find into the original equation. Example, we have an example, a simple example here. Solve square root of x plus 1 equals 5. And what we're going to do here is raise to the power of 2 both sides of the equation. So let's raise both sides to the power of 2, to the square, right? And this is going to be square root of x plus 1 squared is x plus 1, right? And 5 squared is 25. Right now we can just apply addition property and find out the result, right? You're going to subtract 1 on both sides of this equation, and then you're going to have x equals 24. What we're going to do, we're going to get this result here, 24, and let's plug in, let's apply into the original equation, which the original equation, remember, is square root of x plus 1 equals 5. This is the original equation. Square root of 24 plus 1 equals 5. 24 plus 1, 25. Square root of 25, 5 equals 5. True. So we can confirm, you can say, yes, this is going to be the solution that we are looking for. So the step-by-step to solve a radical equation is going to be: step 1, isolate one radical on one side of the equation. Step 2, raise each side of the equation to a power equal to the index of the radical and simplify. And step 3, if the equation still contains a radical, repeat step 1 and step 2. But if not, solve the equation, and then step 4, check. Very important, as I told you, you have to check the proposed solutions that you find into the original equation. Let's try this, another example, and we have square root of x minus 1 minus 1 equals 0. So we have to isolate, check this step by step here. Isolate one radical on this one of the sides of the equation. Let's isolate square root of x minus 1 in one side. We're going to add 1 on both sides, right? Addition property. And then we're going to have square root of x minus 1 equals 1. Now we can raise to the power of 2 to both sides. We're going to square both sides to find a solution, to simplify the radical and find a solution. So x minus 1 squared is x minus 1. Square root of x minus 1 squared equals x minus 1. And 1 squared is 1. That means x equals 2. Alright, then there are no more radicals to simplify. Let's solve. We solve the equation. Let's check, which is step 4. Check into the original. And the original equation is square root of x minus 1 minus 1 equals 0. This is the original equation. Go to the original equation. Plug in number 2. Square root of 2 minus 1 equals 0. Square root 2 minus 1 is 1, square root of 1 is 1, 1 minus 1, 0, 0 equals 0. This is true, so we can confirm that solution here for the original equation. Next example, we have now 2x plus square root of x plus 1 equals 8. So first step, isolate the square root in one side of the equation. Let's subtract, what we're going to do here, let's subtract 2x from both sides. Addition property, so add negative 2x from both sides, so we can simplify here, and then we will have square root of x plus 1, right, equals 8 minus 2x. At this point, we have the square root isolated in one side. Let's raise to the power of 2 both sides of the equation. So let's raise here squared and here as well squared. Square root of x plus 1 squared is just x plus 1, right? And 8 minus 2x squared. Just to remind you, let's apply this special product here, which is, let me write down up here, a minus b squared, squared equals a squared minus 2ab plus b squared. So we're going to apply here on this situation where this is going to be a, this is going to be a, and 2x is going to be b. Okay? So applying this special product, you're going to have 8 squared, 64, minus 2 times 8, 2 times 8, 16, times 2, 32, times x, 32x. So this is minus 2ab, 2 times 8, 16, times 2x, 32x, plus 2x squared, 4x squared. All right, now we have this equation here. We need to simplify and try to find a solution for the resulting equation, right? So what we're going to do, first, let's subtract x and subtract 1 from both sides. Subtract x and subtract 1 from both sides. Okay, and then we're going to simplify this. This is going to be 0 equals 64 minus 1, 63. And negative 32x minus x, negative 33x plus 4x squared. At this point, we are on the step that we don't have any radicals anymore. We will solve this equation, right? We need to solve this equation here. And this is a quadratic equation. There is a section we will study how to solve quadratic equation in a special section of this course. But I will tell you that we can factor out this quadratic equation here in 2 different terms, and it's going to be something like that. One is going to be 4x minus something, and it's going to be 4x minus 21. And the other one is going to be x minus 3. This makes, this is the equivalent, this is the same thing as the quadratic equation that we have here. Equals 0. And the solution for this kind of multiplication here is going to be for each one when each one is equals to 0. So the solution for this one, for this expression here, for this term, will be equals to 0. For x minus 21 equals to 0, x equals to 21 over 4. Okay? And for the whole thing to be equals to 0, this also another solution is for this term, x minus 3 to be equal to 0. That means x equals 3. we have two possible solutions here. 21 over 4 and 3. What we need to do now, remember the step by step, check into the original equation. So bring the original equation back here. 2x plus square root of x plus 1 equals 8. This is the original equation. Let's plug in each one of the possible solutions and check if they are good or not. Let me split, I'm going to split the screen here. On this space, we will work with x equals 3. Let's work with x equals 3. 2 times 3 plus square root of 3 plus 1 equals 8. Let's check if this is true. I don't know yet if this is true. 2 times 3 is 6 plus square root of 3 plus 1 is the square root of 4. 2 equals 8. And yes, this is true. That means x equals 3 is one solution for the original equation. Now let's try the other one. And remember, you have to plug in into the original equation. Now plugging in here into the original equation, the other possible solution, 21 over 4. 2 times 21 over 4 plus square root of 21 over 4 plus 1 needs to be equals to 8. I don't know yet if it is equal to 8. Let's check. 2, we can simplify. Let's simplify, right? Let's simplify. So because 2 over 4 is the same thing as 1 over 2. So 21 divided by 2, 21 divided by 2 is 10.5 plus, and check it out, you don't need even to bother to calculate this. This is going to be a positive number, right? Equals to 8. Do you think this is going to be equals to 8? 10.5 plus another number, another positive number is going to be equal to 8? No, this is not going to be true, right? And we can exclude this. This is not solution for the original equation. We call it an extraneous solution. That means a solution that's not good for the original problem, the original equation, and is not an adequate solution. The only one is going to be x equals 3. Another example. Now we have here, and I'm using blue. Square root of y plus 5 equals 2 minus the square root of y minus 5. And we can, the square root is already isolated here on the left hand side, and we can square both sides of the equation to simplify. And we're going to have y plus 5 on this side, right? Because square root of y plus 5 squared is just y plus 5 equals. And now we can use a special product. Remember this? I'm using green here. This special product, a minus b squared equals to a squared minus 2ab plus b squared. This is special product that is going to apply on this side of the equation, where this is going to be a and that other term here is going to be b. That means, let's apply a squared is going to be 2 squared 4 minus 2 times a, 2 times 2, 4 times b square root of y minus 4 plus b squared, the square root of y minus 4 squared is y minus 4. Okay. And we can, let me see, we can simplify some things here. We can simplify 4 minus 4 is 0. And we're still going to have, the thing that we're going to have is negative 4 square root of y minus 4 plus y. Okay. This remains. And actually now we remember the step by step. We need to isolate this radical now. We need to isolate this one and do the same thing. The first step to isolate the radical, second step to raise to the power, to the same power, both sides of the equation. And let's do it right now. We can actually get rid of the y by subtracting y on both sides, and then we have 5 equals -4 square root of y minus 4. And actually we can square here. Let's just, maybe it's going to be easier. Let's get rid of this -4 as well. So, divide both sides by -4. Okay, let's divide both sides here of this equation by -4, and then we're going to have -5 over 4 equals square root of y minus 4. It's always better to have only the square root isolated in one side of the equation. Let's do the second step, is to square, to raise to the same power both sides of the equation. So we're going to square both sides of the equation. Here we go, and the next thing we're gonna calculate here. Let's raise this -5 over 4 to the square, and negative squared is positive, right? And 5 squared is 25. 4 squared is 16. Equals square root of y minus 4 squared is y minus 4. And we have here a solution. Y equals, add 4 on both sides, addition property of equality, remember, plus 4, and y equals 89 over 16. This is a possible solution. It still needs to be checked. You still need to check it. So let's get this possible solution here. Let me remove this. Okay, let's get this possible solution and check into the original equation. The original equation is going to be this one, a square root of y plus 5 equals 2 minus square root of y minus 4. Okay, this is the original equation. Let's plug in 89 over 16, 89 over 16 plus 5 equals 2 minus square root of 89 plus 16 minus 4. We will work out here we're going to do all the calculations that we need, and this is at the end. You can do by yourself, but at the end you're going to have as a result here. And here, after you do all the calculations, all the simplifications, you're going to find in one side 13 over 4 equals, on the other side 3 over 4. What can you tell about it? Is this true? Is this false? This is false, right? That means this possible solution that we have found is not a good solution. And this equation, the conclusion is going to be that this equation has no solution at all. Okay? This is how we finish this example. This is an equation that's not going to have a solution. Now let's try this next one, the next example. Solve the square root of 2x minus 4 minus the square root of 3x plus 4. And first step, isolate the square root in one side of the equation. Let's isolate this one, square root of 2x minus 4. And actually what we're going to do, we will apply addition property. Let me do this step by step, right? Not skipping steps. Let's apply addition property, and we will add square root of 3x plus 4 on both sides. Add square root of 3x plus 4 in both sides of the equation, because you can get rid of this one, you can simplify, and as a result you're going to have this one here isolated in the left hand side of the equation, equals square root of 3x plus 4 minus 2. Okay, now we are ready to raise to the same power both sides of the equation. In this case, we are squaring both sides of the equation, and as a result, we're going to have on this side 2x minus 4. We got rid of the square root, right? And on the other side, remember this special product. We apply the same special product. This is A, this is B, and the special product is a squared minus 2ab plus b squared. So 3x plus 4, this is a squared, minus 2 times 2, 4, square root of 3x plus 4, plus 2 squared, 4. And at this point, we can check and realize that we still have one square root here. Step by step, go back to first step. Step 1, isolate this square root so we can start all over the step by step and try to solve this problem. Okay, starting by isolating, we're going to isolate this one now, and we're going to move everything here that's everything else to the other side of the equation, right? So let's move this, negative 3x, and 4 plus 4, 8. Let's move 8, and to everything to the left-hand side of the equation. And as a result, addition property, negative x minus 12 equals, and this we simplify, negative 4 square root of 3x plus 4. And I like, let me see this, we're not going to do this now, we will do this later, right? Let's first finish, what we started here. Let's, first of all, let's also simplify this. I want to get rid of this negative 4 and divide both sides by negative 4. Let's divide both sides by negative 4, okay? And we're keeping working down here. Negative x divided by negative 4, negative with negative positive, x over 4. Negative 12 divided by 4, negative 4 is negative with negative positive, positive 3, equals, and negative 4 with negative 4, 1, square root of 3x plus 4. Great. Square both sides, and now we will have here, and keep it working and here underneath. On this side, we will use a special product here, special product. And just remember this special product that you're going to apply, going to use is a plus b squared equals a squared plus 2ab plus b squared. I'm going to use here, this is a, this is b. So x a squared, x squared over 16 plus 2 times a times b, 2 times x over 4 is x over 2, times 3 is 3 over 2x. And plus b squared plus 9 equals, and this is simplified, 3x, we get rid of the square root, right? 3x plus 4. All right, let's go over this one here, and this is also a quadratic equation, and we will move this to the left hand side. Let's apply addition property, and we'll subtract on both sides 3x plus 4. That means negative 3x minus 4 on both sides. Okay. The result is x squared over 16 Positive 3 over 2x minus 3 is negative 3 over 2x. 9 minus 4, 5 equals 0. One thing that we can do is multiply the whole equation, the whole quadratic equation that we have here by 16, and we will have x squared minus 16 divided by 2 is 16 divided by 2, 8. 8 times 3, 24. Plus 16 multiplied by 5 is 80 equals 0. And this is a quadratic equation. We need to find here two numbers. The numbers multiplied are going to be equals to 80. Multiplying the numbers are equal to 80. So let's do here. Multiplying the number is going to be equals to 80. And the sum of the numbers is going to be negative 24. Negative 24. And if you think a little bit about it, you have to find two numbers. The numbers multiplied is equals to 80, and the sum is going to be negative 24. A couple of numbers that we can think about is negative 20 and negative 4. See? Negative 20 plus negative 4, 24, negative 24. And negative 4 times negative 20 is 80. We can rewrite this, and let me borrow some space here. We can rewrite this quadratic equation here. Let's rewrite with the terms, with the factors, right? X minus 4 multiplied by x minus 20 equals to 0. The solution for this, make this equals to 0 is x equals 4, and make this this term or this factor equals to 0, x equals to 20. So we have two solutions. Apply the solutions into the original equation to check if they are good, and bring back the original equation, which is this one here. The original equation, 2x minus 4 minus square root of 3x plus 4 equals 2. Minus square root of 12 minus 4 equals 2. This is what we are, 12 plus 4, sorry, 12 plus 4. And then we're going to have 8 minus 4, 4, square root of 4, 2, minus 12 plus 4, 16, square root is 4. And this 4, this is equals to negative 2, sorry, negative 2. The original equation is negative 2, sorry, negative 2. And then you're going to have negative 2 equals negative 2, and this is true. That means this is a good solution. And when you plug in x equals 20, you're going to have also something that will produce a true statement. Will also produce a true statement. You can do your calculations, you can check it out, but actually it's going to produce a true statement, and this is also a good solution. Don't forget, this is really important, especially on our situation here. Plug in, check the solutions, the possible solutions into the original equation, because we are changing, right? We are changing. When we square both sides of the equation, we are changing the equation. We are creating a new equation. And this equation can have solutions that are not applicable to the original one. Moving on, and let's move to the next example that we have here. Let me just clear this up. We borrow this space. Now we need the space to solve this new question. The square root of x equals -5. This is an example. That's a pretty interesting example. Let's see what happens. We will square both sides. Okay, square both sides. Let's square here both sides and find out what happens. Square root of 5x squared is going to be 5x, and -25 squared is 25. Then divide both sides by 5, x equals 5, right? X equals 5. But think, when we substitute, and this is important, I'm telling you, it's really important, substitute the possible solution that we found into the original equation. So substitute the square root of 5 times 5 equals -5. And this is a question that we are asking. We're going to check it, right? Square root of 25 equals -5. And 5 equals -5. This is not true. This is false, right? This is not a true statement. Actually, it's a false statement. That means the left side of the equation is asking for principal square root. That means this is not a solution. This is not a good solution. This equation here will have actually no solution. No solution, or is an empty set. The solution is an empty set. Let's work now on objective number 2. Use the Pythagorean theorem to model problems. And the Pythagorean theorem: if A and B are lengths of the legs of a right triangle, and C is the length of the hypotenuse, then we're going to have A squared plus B squared equals C squared. The legs is squared, the sum of the legs squared is equal to the hypotenuse squared. This is the usual way you're going to write the Pythagorean theorem. Let's work now. Let's see now a few examples and applications of the Pythagorean theorem. Find the length of the hypotenuse of a right triangle when the length of the two legs are 2 inches and 7 inches. This is just an application of the formula. I just need to plug in the numbers, so pretty straightforward. A squared plus B squared equals C squared, and we have A, we can say A equals 2, and we can say B equals 7 equals C squared. 2 squared is going to be equals to 4. 7 squared is going to be 7 times 7, 49 equals C squared. That means 49 plus 4 is 53. C equals square root of 53. And we have here some unities, and you can say this is in inches. Okay, this is going to be in inches. Next example. Find the length of the leg of a right triangle. Give the exact length and a 2 decimal approximation. Let A equals 2 meters and C equals 9 meters. Again, just a straightforward application of the Pythagorean theorem, the formula. So plug in, we have one leg is 2 squared, and the other legs, the hypotenuse is going to be 9. We want to find here one of the legs. One of the legs, B squared, is unknown, and the hypotenuse is going to be 9. 9 squared. 9 squared. Okay? That means 2 squared 4 plus B squared equals 9 squared is 81. Subtract 4 from both sides of the equation here to apply addition property, right? And we will have b squared equals 81 minus 4, 77. And the question asks you the exact length, and the exact length is going to be, let me use this space here. The exact length is going to be b equals square root of 77. And this is in meters, right? Meters. And also the question is asking a 2 decimal approximation. You just type this in your calculator and you're gonna find, let me squeeze this a little bit, type in your calculator, you're gonna find 8.77. This is approximation, right? This is an approximation. 8.77 meters. Sorry, and this is meters. Yes, this is going to be meters. Sorry about we are squeezed a little bit here, but I run out of space. I'm sorry. Now let's check, let's try, let's work on this new example. And this is pretty interesting because it's a real life application. It's a real situation. A surveyor must determine the distance across a lake at points P and Q as shown in the figure. To do this, she finds a third point, R, perpendicular to line PQ. If the length of PQ is 320 feet and the length of QR is 240 feet, what is the distance across the lake? Approximate the distance to the nearest Whole Foods. So let's use the Pythagorean theorem to solve the problem. C is 320. We can see this sketch here, right? We can see this, and C is going to be 320. We can say A equals 240, and we need to find B, right? Let's apply. Let's apply here the Pythagorean theorem. A squared plus B squared equals C squared. And we have A is 240, 240 squared plus B squared equals, and C is 320 squared. Okay? 240 squared is going to be, and then I think you're going to need a calculator, right? So you can find out 240 squared, 57,600 plus B squared, we don't know, we want to find B. And 320 squared is going to be 320 times 320, 102,400. Okay? If you don't believe me, type in your calculator, you're gonna find these numbers. Apply addition property. I like to do this step by step so you understand what I'm doing. I'm applying here addition property to get rid of this. So subtract 57,600 on both sides of the equation. And then you find out B squared, right? B squared equals 102,400 minus 57,600 is going to be 44,800. And then B equals square root of 44,800. Use again your calculator, you're going to find. You can simplify, actually you can factor out, and you will be able to simplify and find 80 square root of 7. If you factor out 44,800, you're going to find that 44,800 is equals to 80 squared. Oops, let me just fix this square here. 80 squared times 7. And then you're going to have 80 square root of 7, which is approximately, and the question asks you to approximate to the nearest whole food. Approximate to the nearest whole food. So we will approximate, don't want decimals, just the nearest whole foot is going to be 212 feet. Okay. The distance across the lake is about 212 feet. This is the answer to this kind of real life situation or real life problem. That's it. This is the end of section 7.6. Thank you very much for watching.